Good morning, everyone. My topic today is numerical integration. Numerical integration is a very useful tool in computational applied mathematics. And I will talk about the reason for numerical integration and several basic rules to do it. So why do we need numerical integration? The short answer is because analytic method fails. Let's consider this example. The first one, the integration of x squared from 0 to 1. It is very simple, you see, because we can easily find an antiderivative which is x cubed over 3, right? So the answer is 1/3. But what about the second one? So x up to the 10th multiplied by exponent of x. This one is much more complicated. We can calculate the integral, say, by integration by parts, but it can be very boring. It is still solvable, but the third one, exponent of minus x squared. Do you have any idea to solve it? Actually, it is impossible to find an antiderivative of this function in the elementary form. So it can be difficult, boring, or impossible to find an antiderivative. This is why we need numerical integration. And a simple method to do numerical integration is midpoint rule. Say if we want to integrate fx from a to b, then we use its value at the midpoint a plus b over 2 to approximate fx. Since this is an integral, of a constant function, and it is very simple, right? So the result is b minus a multiplied by f at a plus b over 2. This is midpoint rule. And geometrically, midpoint rule is to approximate the area and the curve of fx by the area of this rectangle. And another method is trapezoid rule. Trapezoid rule is to approximate fx by the average of fa and fb, and the result is b minus a multiplied by the average of fa and fb. This is trapezoid rule. And geometrically, trapezoid rule is to approximate the area and the curve of fx by this trapezoid. So it is called trapezoid rule. And as you can see, these rules are very inaccurate approximation. So in order to get result more accurate, we need composite rule. That is, divide the interval AB into n small intervals. And then use midpoint or trapezoid rule to calculate the integral in every small integral, and in every small interval, sorry. And finally, sum these integrals up. This is composite rule. And as you can imagine, the larger n is, the more accurate the integral will be, which is very clear in this table. If we see this color, you can see larger n is, the smaller the error will be. What else can we see from this table? Well, if we compare the number in the same row, the error in trapezoid rule and the error in midpoint rule, we will find that they have different signs. This is one is negative and the other is positive. Moreover, the magnitude of the error in trapezoid rule is about twice as big as the error in midpoint rule. This equation. And from this equation, if we move the 2 multiply midpoint rule from right hand side to left hand side, and move the integral of fx from a to b to the right side, and then divide the whole equation by 3, then we will find 2/3 of midpoint rule plus 1/3 of trapezoid rule is very close to the exact value of the integral of fx from a to b. This is nothing but simplicity rule. And as you can see from this table, the error in simple syndrome is much, much smaller than the error in both the midpoint rule and trapezoid rule. So today I have talked about why we need to do numerical integration and several ways to do it, including midpoint rule, trapezoid rule, composite rule, and simple rule. And I have time for your questions now.
Usually, which rule you use the most?
Well, simple syndrome is much more accurate, so we prefer to use this one. And there are some more advanced methods to calculate the integral. Did I answer your question?
In simple syndrome is empirical principle, all can be reduced theoretically.
It can be reduced theoretically. Actually, if we try to find this quadratic function, that is this function, we try to use this function to approximate fx. And we want such result that J equals to Fa and JB equals to FB, and J at the midpoint equal to F value at midpoint. Sorry, I shouldn't write ABC. Maybe okay. Oh, yes, alpha, beta, gamma. Yeah, and from these three equations, we can solve out alpha, beta, and gamma, right? And then we can find the integral of fx from A to B. It's simple syndrome. So it can be derived theoretically in this method. Did I answer your question?
So do you usually calculate those complicated equations
sure.
by hand without computers?
It's terrible to calculate by hand. So usually we use computer to calculate.